All right, everyone, welcome back to EM378 SI Online. This will be our last problem that we go through for review for the exam that you guys have tomorrow. So just as way of announcements, no session Tuesday or Thursday this week. That's because of exam. But so that's this week. But next week, regular session times. So make sure that we're in the last stretch of the semester. I think the things that we're going to be going over for the rest of the class won't be too bad. So come to SI, hit up a couple of those, and you should be all set for the final. So, alrighty, let's get into this problem. So we have a motor-driven centrifugal pump. This is the pump. Delivers 15 degrees Celsius water at a rate of 10 meters cubed per minute from a water reservoir through a 2,500 meter long 30 centimeter ID plastic pipe to ID is internal diameter, just in case just in case you hadn't seen that before. So 30 centimeter internal diameter plastic pipe to a second reservoir. The water level in the second reservoir is 40 meters above the water level in the first reservoir. The pump efficiency is 75%. Find motor output power. The pipe entrance is square edged. Alrighty, so power output, that's W dot in terms of variables. So that's what we're going to be solving for. And anytime you got something that looks like this, you'll be using Bernoulli. So P1 over rho plus B1 squared over 2 plus GZ1 plus GHP is equal to P2 over rho plus V2 squared over 2 plus GZ2, that's a 2, GZ2 plus GHL. And a couple things that we know, since these are the surface of two large tanks, pressure 1 and pressure 2 are both going to be 0. Same with their velocities. And the difference in elevation, we'll just call Z1 0 and Z2 is 40. So once you have those, a lot of stuff falls away, and so the equation you're left with is 0 plus 0 plus 0 plus G times HP is equal to 0 plus 0 plus G times 40 plus G times friction times L over D, diameter, plus sigma KL multiplied by V squared over 2G. All right, and so things that we don't know right now, we know the elevation here, or yeah, that's why I plugged that in. We know the length, we know the diameter. Sigma KL, what we know is that the pipe entrance is square edged. So we know that, so if this is square edged and this is square edged, we get a KL at the entrant of 0.5 and a KL at the exit of 1.0. So sigma KL is just 1.5. And then the other things that we need to solve for are this velocity and this friction factor. And to get the friction factor, we're going to need the velocity anyway because we're going to be calculating a Reynolds number. So velocity, that's just flow rate over the area. So flow rate 10, this is in meters cubed per minute, if this will focus for us. Wait for it. There we go. All right. So we're going to convert that minute into seconds because we're going to be using gravity in terms of meters per second squared, so we don't want to mess that up at all. And the area that we have, there's our diameter because it's given in centimeters, multiplied by pi over 4. Velocity you should get is 2.36 meters per second. So follows that our Reynolds number, which is Vd over nu, 2.36 times 0.30 over 1.15 times 10 to the negative 6th. That gives us 6.15 times 10 to the 5th, which means that we have turbulent flow. Which means we're going to have to either look at the Moody chart or Kullback and Holland equation. Since we know what our Reynolds number is, and we know, and it's an actual number, and then we can get our epsilon over d because we know it's a plastic pipe. We can look that up in a chart, and using our epsilon over d and our Reynolds number, look at Moody chart, and we should get what should get friction factor is 0.013. Don't worry about knowing relative roughnesses, or anything like that. Those are ready. Cool. Those would all be given to you in an exam, so there's no numbers that you have to memorize. Same with these KL values, these losses. Those would be given to you in a table or chart. Don't try and memorize those. Or you could, but I mean, they'd be given to you, so it wouldn't really be worth it. All right, so then we have 9.8 times HP. We're going to plug these two values in to our equation up here. So 9.8 times HP, 9.8 times 40, plus 0.013 times our length of 2500 over our diameter of 0.30, plus our sigma KL we got up here, multiplied by our velocity squared over 2, right? Because this gravity cancel out there, so we don't have to write that down here. Multiply all of this out, and we get 698. All right. So W dot, that's equal to rho Q G H P. But one thing that we were given is that the efficiency of our pump is 75%. So what that means is we're going to divide by that efficiency. I tried to draw that. Wait for it. There we go. It's like a weird looking N thing. Yeah. So if your efficiency is only 75%, that means the actual power output of your pump is going to be more than the value that you would calculate, because you're only getting 75% of the juice that you're putting in. So you divide by that 75%. So numbers that we're putting in, 999 multiplied by 10. This is seconds per minute. This is meters cubed per minute. So this is just a conversion here. This isn't a new number because this is our flow rate. Divided by that to get into seconds. G is 9.8. So G times HP, that's this 698. So we don't have to multiply by gravity there. That's why we left it like that. You could divide by G and then just multiply it again, but not really worth it. And then divide by our efficiency of 0.75. And we should get W dot is equal to 155 kilowatts. So the number you're going to get up here is a large number, and that would be in watts. So convert that to kilowatts. Alrighty, so that's this problem that we have here. Remember, this week we're not going to do a session Tuesday or Thursday because of the exam. The exam starts during our regular session tomorrow, so that'd be a little weird if we were having a session during the exam. Thursday, since we're not going over any new content and we had that 2-hour review session yesterday, I figured I'm all capped out in hours after today for the week. So just to keep that in mind. And anything else that I have to say? Not really. Good luck on the exam, everybody. I hope that these videos have been helpful. If there's any way that you want them to be more helpful, get any feedback like that, make sure you can leave a comment or go to the SI website and you can send me a message through there. All right, everybody. Good luck on the exam. Hope you do extremely well.